Hi everyone, in this tutorial I'll explain how to open, modify and save in 3D Slicer the file that we want to measure. Go to the folder and open the scene.mrml. 3D Slicer displays the three views of the CT scan and a window with the 3D model, while on the left there is the space for the modules. As seen in the top menu, the one shown is the Welcome module. If we open the drop-down menu, we can select what we need. For example, we click on the Data module. Here we can see the patient, the CT series for the hip, femore, knee, ginocchio, and ankle, caviglia. Below, there are the 3D models that were manually segmented and imported. It may happen that the hip is missing in the 3D view, but you can still find it among the models. This is a trick to keep the format identical for all the files. The hip is not really important and could have been omitted. In fact, we hide it immediately by clicking on the eye icon next to it. Further down, we have the landmarks, which are still empty. Let's start selecting the volume named Femore. Select Markups in the top menu, then select Femoral Head. It's very easy to forget to select the right markup, so please double check that you have done it. Otherwise, you'll assign the point to the wrong landmark. Double-click on the 3D view or click on the following icon. Select Place a control point. The option Place multiple control points should already be selected automatically. Start positioning 30 points on the femoral head. As you can see, the label femoral head appears next to each point. Pay attention to it to make sure you have selected the correct markup. This operation doesn't need to be extremely accurate. Use zoom and rotate the model to cover the whole surface of the femoral head, avoiding the neck and the ligament fossa. 30 points is a convention. I found it to be the right amount to properly cover the surface. Since the algorithm searches for the best fitting sphere to this sequence of points, technically 4 points would be enough and there is no maximum number. However, using only 4 points can be misleading, while around 30 is a good compromise. Once you have finished, toggle the visualization off by clicking on the eye icon next to the femoral head and continue with the next step. Double-click to reset the view and click on the FNC to select femoral neck center. This point, by our definition, is the centroid of the minimum section of the femoral neck. To find it, make sure that the crosshair is visible, then, starting from the coronal view, point the mouse at the isthmus of the neck and press Shift. As you can see, all three planes are linked. You can adjust the position on the sagittal and axial views. Once you find approximately the center, just click and assign the point. This point will be refined by the algorithm later. Just for explanatory purpose, I'll now show how to get another view of this point. Go to the Data menu and by right-clicking on Femore Prox, change the opacity in order to see through the segment and visualize the point assigned. Restore the opacity and go back to the Markups menu. Toggle the visibility of FNC and select the next landmark. Back to Data menu, select the volume, ginocchio, and again go to Markups. FMCP stands for femoral medial condyle posterior, defined as the most posterior point of the medial condyle. The purpose of these 2 points, medial and lateral, is to trace the PCL, posterior condylar line, which is the line tangent to the condyle. For this reason, we enable the multiplanar reconstruction, that's the icon at the top of the window, and we toggle on the interaction command. We also disable the crosshair button once we find on the coronal view the most posterior point, either medial or lateral, it doesn't matter. On the axial view, we rotate the coronal plane, the green line, until it becomes tangent to both condyles. Small adjustments can be made if necessary. And after that, toggle off the interaction command. It may happen that the segmentation doesn't perfectly match the CT scan. This is usually a small imprecision on the order of 1 or 2 millimeters. Anyway, if the segmentation is not precise, assign the point where it should be, even if it is floating in the air or penetrating the model. As a golden rule, we always assign the medial point first and then the lateral one. Once FMCP and FLCP have been assigned, toggle their visibility off. Next, select FMC FLC, which represent the most distal, medial, and lateral points of the femoral condyles. These points are also useful for tracing the line tangent to them, commonly called the femoral joint line, which will later be used to calculate LDFA and JLCA. Now, on the axial view, find the most distal point, either medial or lateral. In the coronal view, rotate the axial plane, the red line, until in the axial view you can see the most distal point on the opposite condyle. Finally, toggle off the interaction command, check the point placement in all 3 views, and make small adjustments if needed. In the lateral view, it's easy to verify whether the selected points are truly the most distal ones. Now you can toggle off the markup visibility. Next, select femoral trochlea, which we define as the most caudal point of the femoral trochlea. Reset the MPR view by toggling the visibility of the volume ginocchio, then switch off the visibility of the rotula and zoom in on the trochlea area. Toggle on crosshair and toggle off the MPR. Press Shift when the cursor corresponds to the femoral trochlea in the 3D view. Now look at the axial view and scroll through a few slices until you find the level where the medial and lateral condyles are no longer connected. To be sure, double-check in the sagittal view. Finally, select the most distal point of the femoral trochlea and assign the markup. Then toggle the visualization off. Next, select TMS, TLS, respectively the tibial medial and lateral spines. In the data menu, toggle off the visibility of the femur. In the markups menu, make sure that TMS, TLS is selected. Toggle on crosshair visibility, and on the axial view assign the 2 points, first medial and then lateral. Then toggle the visualization off. Next, select PPT, posterior proximal tibial, which we define as the most posterior point of the tibia on the axial slice just above the fibular head. Again, the purpose is to draw a tangent line at the posterior aspect of the tibia, which will be used for the calculation of tibial torsion. To do that, once we find the right axial slice just above the peroneal head, we toggle on the MPR and interaction buttons. We select the medial or lateral most posterior point, and on the axial view, we rotate the coronal plane, the green line, until it is tangent to the posterior aspect. On the coronal view, you can see at the level of the red line the posterior aspect appearing. It doesn't matter if there are already some bone structure visible, usually above this red line. We are searching at the level of the fibular head, and we don't care about the most proximal part of the tibia. Then toggle the visualization off. Let the MPR as it is. Select TMCA, toggle on the visibility of the coronal plane in the 3D view, and look at the tibial plateau from the top. Usually, the plane or line that crosses the medial and lateral hemicondyles and passes through the spine is slightly shifted backwards on the medial side compared to the original CT reference system plane. We found that keeping the same orientation used to identify the posterior proximal tibia matches well with the suitable orientation for evaluating the tibial plateau. Once we ensure that MPR orientation is correct, move the sagittal plane to the middle of the medial plateau. You can also toggle on the visibility of the sagittal plane and double-check in the 3D view. At this point, you can set the landmarks, respectively the anterior and posterior points on the sagittal view, considering only the inner part of the plateau. Then, on the coronal view, set the most medial point of the plateau. Then toggle the visualization off. And repeat the process. There is no need to change the coronal plane. Simply move the sagittal plane until it is centered on the lateral hemicondyle. Once correctly positioned, assign the points anterior and posterior on the sagittal view and the most lateral point of the coronal view. And toggle the visualization off. Also, the visibility of coronal or sagittal plane. In the data menu, select the volume caviglia and toggle off the visibility of the proximal tibia and fibula. Go back to the Markups menu, select TMP, the points on the tibial plafond used to find the center of the distal tibia. On the axial view, search for the slice where the malleus and, most importantly, its isthmus are visible. Usually, at this level, the distal tibia and fibula, as well the shape of the malleus, can be clearly identified. On the axial view, rotate the coronal plane, the green line, until it crosses all the previous segments, and make sure the sagittal plane, the yellow line, passes through the isthmus. Keep this configuration and start assigning the next 4 points. On the coronal view, the tibial, medial, and lateral plafond points are the most cranial points at the medial and lateral borders of the plafond. They don't necessarily need to lie on the axial plane, the red line. And on the sagittal view, the anterior and posterior points are the most caudal points, and again, they don't need to lie on the red line. Double-check the medial and lateral points by moving the axial view until it reaches the tibial medial plafond. Usually, the anterior and posterior points don't require any adjustment, but you can visualize them by scrolling distally if needed. Finally, toggle off the visualization of the landmarks. And that's all. Now we have assigned all the landmarks needed for the code to compute the angle measurement. Saving now will store the scene and the landmarks with the points and coordinates we have assigned. Just click on the Save icon. You can see the file path, which corresponds to the location where the file was originally opened. In this case, simply press Save.